Test, test. Is it working now? Can you make, yeah. Good morning. Thanks for coming. Today you're going to learn everything, maybe not everything, but a lot about the programming language, well, the shell bash. And I'm sure you have seen the bash shell before. Essentially, whenever you open a console on your Linux system or your Mac system, the terminal, then what you have in front of you is the bash environment, and you can type in commands, which I'm sure you've done already. But I want to show you some more tips and tricks how you can get more out of the bash shell and how you can actually write simple programs in the bash. But before we dive into the technical details, some organizational things. So remember that the first assignment is due this Friday. So make sure that you have committed your solutions of the first assignment into the private GitHub repository within this organization, the EN3110 organization. And so I know that some students are still on the waiting list to sign up for this course. So I will talk to the administration later today and ask them to open up the registration again. I can't promise anything, but I will try at least. So one more comment. So if you're sick, of course, you can ask for an extension. So the way this works is that we will automatically grant you a 3-day extension if you're sick. So I'm not going to check every single case here. And requesting an extension is fairly easy. So if you go to the web page and you scroll down here on the bottom, you find a link here, and you just essentially type in. We only need your username and the assignment that you're currently working on, and then you'll automatically get a 3-day extension. So that's how that works. And then if you have any problems with the repository or any questions, then just feel free to ask me. So then assignment 2. So that's this assignment on bash, which I'm going to teach today. That's published now on the website, so you can download it. And you will have 1 week to correct it. I'm sorry, this should be next Wednesday, not next Tuesday. And also we will publish optional group exercises if you want to do these in the group sessions. And I just had a group meeting this morning with the correctors, and we discussed that it would be nice to make the group sessions a bit more interesting. So from next week on, we will have some quizzes in the group sessions. There's this, I'm sure you know this Kahoot, I think it's called. Yeah. So they will prepare some Kahoot questions for you next week if you go there. Any questions regarding assignments? No? So then let's dive in straight to bash programming. So just to give you an overview, so the bash is really one of the, comes out of the Unix system. So I want to give you a quick historical overview of the different Unix shells that exist or do not exist anymore. So essentially all the scripting languages that existed were originally extensions of command line interpreters, right? So specifically for the operation systems. So I mean, of course, Microsoft developed DOS, but even before then, there were quite a lot of Unix shells available, typically mostly accessible through on supercomputers in universities. And kind of the first shell was called the Bourne shell. Just the name was called SH. And then people started kind of developing extensions to that and improvements. So there's the C shell and the Tcl shell. but they never really catched up on the popularity of this original Bourne shell. And then kind of this entire open source movement happened with Linux, and of course also an open source alternative to the Bourne shell was developed, and that was called Bash, and is still called Bash. So the name comes from Born Again shell. So it's essentially an open source version and an improvement of the original Bourne shell. And that is the one that you essentially have more or less on every single Linux system today and every single Mac system. And nowadays even on Windows systems. And so of course people developed also alternatives. So there's a Dash. If you have Ubuntu, then by default you're actually starting Dash, but it's quite compatible to the Bash. There's a Korn shell and a Set shell, and there's kind of various different flavors, and they're very interesting by its own. But the Bash is the dominating shell today, and that's also the reason why I teach it. But if you're interested, I encourage you to also look into other shells, and who knows, maybe you end up using something else. So, of course, the question arises why you should put effort into learning Bash. It can be quite obscure at sometimes, and you can tell that it's maybe not the most modern language. But there's a few good reasons. So first of all, learning Bash means learning Unix, and that's a kind of a very successful operating system that we can definitely learn from. Then it also, learning the Bash really means kind of where the scripting languages stem from. So this is really kind of the roots of scripting. And but even maybe from a practical perspective, more important is that you will meet shell scripts in almost every single larger projects. So whenever you're working in larger projects, you will need to handle shell scripts at some point. And it's, as I already mentioned, it's widely available. It's open source, and it's the dominating shell that you find on today's Unix systems. So what are these shell scripts then used for today? So mostly they're used to glue together larger programs. So if you have, maybe you've developed a piece of software that does a specific task, and you want the output of that program to be used as an input to another program, right? So for these kind of interactions, Bash is very suitable. So often I write my scripts in Python, and then if I have multiple scripts, I glue them together with a shell script. But another typical use case is that if I have an idea of implementing something, I want to kind of evaluate that idea as quickly as possible. And quite often, a good idea is to just code up some sequence of commands that implements that idea or that I use often, and I just put them in a file, and so to avoid repetitive tasks. But then maybe that's a bit too restrictive, right? It's not very flexible. So then what you do is you add command line options to your script, to your Bash script, so that you have a few more options on the sequence of commands that you're executing. And then kind of the next step is, okay, so you want your program to become even more flexible, so you introduce variables. Maybe you want to do some error checking with if tests. Maybe you want to introduce loops for even more complex program flow. And then at some point, your script is maybe used even by other people, and then it becomes too advanced for the Bash shell, and then it's time to reprogram it again in another language. And then maybe Python is a good choice or something else. But the point is, it's kind of a very, very natural workflow. You start with the simplest possible solution for your specific problem, and then it grows within the shell environment, and then as soon as you hit the limits of the Bash shell, then you can move to another programming language. So all these examples that I'm going to show you today, they can be run under Bash, but also under the derivatives like the dash that you will have on Ubuntu. So just to make you aware of the differences on the operating systems. So on Mac you have the shell available under bin/bin/sh, and but that's essentially a link to the Bash, which is the program is called /bin, or it's installed under /bin/bash. On Ubuntu, as I mentioned, you have /bin/sh is a link to dash, which is a smaller version of Bash, but it's much faster. And then if you're on Windows, you have two options. You either install Cygwin, so if you Google that, you'll find instructions how to install Cygwin, or you can install the Linux subsystem in Windows 10, which also gives you a shell environment. And then here's some reference material if you want more information. So just highlighting again, what are in which cases, if you, yeah.
You tried cutting off some bytes.
Yeah. Let's see. Oh, that was useful. Okay. It's better?
Yeah.
Okay. Okay, here's so if you have a specific task, here's when you should consider Bash. So Bash is really good if you need to do some operations on your file system or directory management. Maybe you want to delete some old files, or you want to move, maybe you have loads of files collected and you want to kind of compress them together or move them somewhere else, then consider Bash. Anything that has to do with system management. So this could be compiling a program, doing some cleaning up or backup procedures, right? So these are often typical written in Bash. Then combining multiple Python scripts or other scripts together. I'll show you quite a few examples on that. Then rapid prototyping. So just as I mentioned before, if you want to test a simple idea, then often Bash can be used. And then if you want to do very simple output processing, or maybe even plotting of some data, but the focus is on very simple, because Bash isn't particularly good at that. So what is Bash not good at? Anything that it's actually surprisingly not particularly portable across different platforms. So you might experience that if you program your Bash script on a Windows system and then you try to run it on a Linux system, you'll hit loads of special cases, right? So already the file structures are different, and so that's actually quite problematic. Then Bash essentially doesn't have good support for any graphical user interfaces. You can't really connect it to existing libraries that you might want to use. As I mentioned, it doesn't have any libraries for plotting or post-processing. And also, if you want to do some advanced calculations or maths, it's simply not fast enough to do that. So some common tasks that you would want to program in Bash. Writing some simple files, for loops, running an application, combining applications, file clopping. So all of these you will learn in this lecture. Testing if a file is of a specific type, managing files, that includes creating new files, deleting files that you don't need anymore, renaming files, going through a directory structure and operate on that, and then packing or zipping entire directories and unzipping them, of course, again. So let's get started. Our very first Bash example is a simple hello world, of course, and that's what it looks like. So you need 2 lines. The first one simply tells the interpreter in which shell it should run. So here I specifically tell it that it should be the bash shell. And then here I have my echo command. Echo is essentially the print in bash. So, and we don't need any brackets. We can just write echo and then the string that we want to output. And so if I run this, I can do this interactively here, then the output is, as expected, hello world. And so just to prepare you for this lecture, so whenever you will learn a lot of bash commands here in this lecture. So whenever I introduce a new command, you'll see this red explanation mark, and I have a sentence saying what this command does. Right, so echo prints text to screen. So simple. Okay, so how do we now run this script? We have 2 options. We can either type the echo command directly in the shell, in our terminal. Of course, that's only feasible if you have kind of a 1-liner or 2-liner script. But if you want to use your script multiple times, then it's best to save the code in a file. So a typical one uses the file extension .sh. So you might want to choose hello world.sh. Save the code in there, and then you can make it executable. So this change mod makes a file executable in Unix, and then you can run it with ./hello world.sh. If you do that, you would get the same output as I did just now. So here's a quiz. How does, so if you created now this file hello world.sh and you run this command here, how does the operating system know that this is supposed to be a bash script and be run through the bash interpreter? Any ideas? Yes. So the first, so kind of one idea could be to say, well, it's because of this .sh file extension, but that's actually not the case. So bash scripts can have any names. If you're evil, you could call it even .py, right? You really shouldn't. But oops. The reason why it knows that it's a bash script is because of this first magic line in our script where we used $!bin/bash. That tells the operating system the following file is a bash script. I'm supposed to execute it with a bash interpreter. And in fact, you can also, if you write a Python script, you can do exactly the same thing. I mean, if this was Python code, you could do /bin/ I think might be user bin Python. But essentially, you need to provide the path to the interpreter that you want to run this file with. Okay, so the answer is the first magic line in the script tells the operating system which shell interpreter to use. If you don't have that line, then I think you need to actually, I don't think this will work. So okay, let's make our example a bit more interesting. Let's add a variable. So variables are defined simply by the name of the variable, equal, and then the value. And then you can substitute the variable name in a string like this. So you use the $ and then the curly brackets. The curly brackets are actually optional. And so then in that string, the value of that variable will be substituted in here. So I can run that again. And you get hello world Simon. So I just want to, as I mentioned, you can also get rid of these curly brackets. They're not strictly needed. The problem is, what if you wanted to what if you wanted to say output hello world Simons, right? Then you kind of need to add the S here, and then Bash thinks you're looking for the variable $names, and of course that one doesn't exist. So you just get an empty value here. So for that reason, it can be useful to use these curly brackets, because you're explicitly saying I'm looking for the variable. My variable name stops here at the end of the curly bracket. Okay, still fairly simple, but now it becomes more interesting. So now, let's say we want to extend our program that it says hello world Simon, but it also should tell me the current day of the week. So the first part of the program is the same, hello world Simon, but now how do we get the current day of the week? So it turns out there is a bash command for that, and it's called date. So we can test it here. So I'm in a bash here, and I can type in date, and then you can see you get kind of an extensive information about the current date, and then you can also add some formatting options. So if I add this plus, and then you can look up in the manual that this essentially reduces the output to only the day of the week. Okay, so we have a bash command that outputs the day of the week, and now we want to use that output within our own bash command. How do we do that? We use the $ symbol, and then with brackets, we type in the command that we want to execute, and then the output can then be stored in a variable. So weekday will now be containing the day of the week, and we can use it just as we're used to in our echo command. So you can run that, and we'll see it works. So just a warning here, Bash can be sometimes quite strict on how on its syntax. So sometimes you might be surprised that things don't work. So again, a little quiz. What do you think is going to happen when I run this line of code here? Any ideas? Sorry? It evaluates what? Okay, maybe it's a condition and evaluates the condition. Yeah?
Get an error because of the spaces.
Yeah, so of course what I want to do is here I want to assign 5 to the my variable. But what actually happens is that Bash thinks I'm calling a program called myvar, and then I supply 2 command line arguments. The first one is equal, and the other one is 5, right? And of course, that doesn't make any sense. So you really have to make sure that you're removing all the spaces in between such that the veil assignment works as expected. And so, I mean, in this case, we need to remove spaces. I'll show you another example later where you must have spaces. If you don't have spaces, then it also doesn't work. So, but for variable assignments, remember to remove the spaces around the equal sign. Here's another useful debugging tool when you have a larger Bash script. So sometimes, so the situation that you might be in is that you've written kind of 50 lines of Bash code and you run it, and it doesn't show the output that you're expecting, right? So potentially what might happen is that you have some if conditions, and for some reason you're going into kind of an incorrect if condition. But it might be very difficult to figure out what is going wrong. And so then what's really useful is in your first line, just where you specify the interpreter, add the -x flag. And what that will do is it will print the line that it executes. While executing, it will also print the lines that it executes. Okay? So just to give you a quick demo on how this works. Let's see. So I have this backup script here. Oh, and here I actually fixed it already. Okay, so, well, oh, no, so I haven't fixed it yet. So this backup script, right, what it should do is, I haven't explained all the syntax, but it doesn't matter. So what it should do is I should check if essentially if the date is on Wednesday, and then it should start the backup, and otherwise I don't do anything, right? And so if I run this now, the problem is that it says no backup today. And I don't really have an idea why it does that, because the code, I mean, it's just just an if-else statement, right? But it becomes much clearer if I add the -x flag here. And then if we run it again, so now you can see that here is the evaluation of the if condition, right? And I'm comparing 1042 with to Wednesday, right? So clearly, I was supposed here, I wanted to get the day of the week, but instead I was kind of getting the count time. So clearly, the command that I'm executing, which is the date plus %r, this is where the bug is. Here I want to have the day of the week. And if I look at the manual, it turns out that I need to use capital A instead of capital R. So then I can go back to my code, change it to a capital R here, and run it again. And so, okay, it's still the debugging symbols are still on, but you can now see it's going in the right if condition and starting the backup. So that's what I wanted to show you with this -x flag. Just one more comment on the variables. So by default, variables in Bash are untyped, which means, well, they don't have a type attached, and they're typically treated as character arrays. So the reason why you need to be aware of that is because if you do something like x equals 5, x equals $x plus 5, and then you try to output it, the output is just going to be 5 plus 5, because this is a character string, and then plus 5 is also interpreted as a character array. It's maybe not what you want. If you want to specifically work on integers, let's say, you can declare the type of the variable. So if you type declare -ib, so -i stands for integer, and then b is the variable name. And so now you created a variable a equals 5. This might be a string, but now if you write $a plus 5, the output needs to be stored in an integer value as in an integer variable. So Bash will then treat this as an integer operation and return 10 as expected. And then, of course, certain things are not valid anymore. So if you try b equals hello, but b is now an integer variable, so it will actually just ignore that statement, and you get 0 as a default value. So another types of variables that you might want to use, read-only variables can be declared with -r, and arrays can be declared with -a. And you can set here already provide 2 values in that array. And then further down here is the where you can access the different array components. So you use the square brackets and then the index. Here I get the first component, which is foo. And if I use the 1 here, you'd get the bar. If you want to have all the array values, you use the @ symbol. And if you want to get the number of items in your array, use the hash symbol. Okay, it's maybe not the too familiar syntax, but it's not too difficult either. Okay, so these are kind of the very basics, but now comes the, I think, the most exciting part of Bash, and that's to combine multiple Bash, to combine commands together. And just to give you again some motivation on why this is so powerful, it's really one of the core concepts of Unix. So in Unix, what you have is essentially the Unix environment provides you with a bunch of very simple programs that do one task only, a very simple task, but they typically do their task very well. And I'll show you some of these. Well, I hope to teach you the most important programs that you might want to use in practice today. But the point is, once you combine these simple programs together, you have a very flexible environment to create more complex operations. And Bash gives you exactly that environment to combine these tasks. Now, how do these tasks work, or these programs work together? It's based on text. So one program outputs text, and the other one takes the text as an input. Right? And yeah, and so that makes it fairly easy to send the output of one file, of one program to the to another one as an input. So just a first motivation on how powerful this is. So let's say you want to write a small script that prints out today's weather forecast in Oslo. And this is the solution written in Bash. And so we'll go through this in detail later. But essentially what I'm doing is I'm downloading the Ur website. Then I'm looking for text snippets that contain the word temperature. Then I'm extracting the first one of these. Then I select the relevant column in the text that I want to display. And then I output it. So let's see if this works. I've tested it yesterday. It's still working. Yes. So we have 22 degrees. Feels like 22, and it's for the period at 11 o'clock, which is just now. So here we've used kind of a bunch of important Unix commands. So curl, oops. The program curl downloads web pages. Grep takes input text and filters lines that have a specific keyword. The head command takes the input and limits the output to only the first X lines. Cut takes the input text, interprets this as a table where you specify a specific delimiter to separate the columns, and then you can select a subset of the columns as an output. And then, well, the last one outputs text such that a cow says it. So, not sure if you're going to use that one, but okay. But so how does this? So I mean, the trick here was that all these different programs talk together, right? And so in order that I can explain this properly, I need to tell you a little bit on how Bash processes work, especially inputs and the outputs of a Bash process. And so essentially, when you start a process, it can receive inputs from, for instance, a keyboard, and this text is passed through a stream called the standard in stream. So any input from the keyboard will be passed to the process through this standard in stream. And then the process might give you some output. And the process has two options to output that. Either it uses the standard output stream that by default is displayed to the screen, and that stream is used for normal messages. But if error occurs, then it uses a different stream, namely the so-called standard error stream. Again, this is by default printed on the screen, but it's on a separate, it's a separate stream is used. And the reason for this is because we will, in a second, we will learn how to change the output of the streams. Maybe some of it should go to another program, another stream should go into a file or things like that. So I just want to give you a live demo on how this works. So there's a new command that you're going to learn. It's called BC. Okay, you don't need to read my Slack. So BC is a bash calculator, and if I start it, it's now waiting for input. So now I can type in a formula, for instance, 1 + 1. If I press return, this text is now passed through the standard input stream to the calculator. The calculator does its calculation, and it outputs the result to the standard output stream, which is displayed on screen here. And then if I do a mistake here, so I don't know, I type in a formula that is not really a maths formula, then I get a syntax error, and that is now passed to the standard error stream, which again pops up here on my screen, but that's simply because both of these streams end up by default on the display. Okay, I hope that's fairly clear. So the first thing that we can do is we can redirect certain streams to a file instead of coming from a keyboard or going to a screen. So how do you do that? For instance, if you want to output the standard out to a file, you use so-called bash redirects. So it's the larger sign. So essentially, in this example, the standard output of my script will, instead of being printed on screen, will now be stored in a file. But if an error message appears, which goes through the standard error stream, it will still appear on the screen because we haven't redirected the error stream. You can also use a double larger sign to, so in the first example, it would always create a new, if the myfile.txt already existed, it would delete it, and it would essentially delete the old content. But if you just want to append the output to that file, then use the double larger sign. This also works the other way around. So if you have text that is supposed to be the input of a program, then you can, or in other words, you want to redirect the standard in stream instead from coming from the keyboard, it should come now from a file. So the way you do that is use this smaller symbol. So this WC command prints new lines, words, and bytes, counts for a file. So it essentially creates some statistics on your file. So let's say you're interested in how many text your thesis already has. Then you can use WC minus W. So I'm only interested in the word count. And then you provide your thesis as a text file as an input. And then you can also combine. You can redirect two streams. So the output of this first command is going to be the number of words in your thesis. But if you want to store that as a text file, you can redirect the standard output to another file here. Okay, so here we've used two redirects. So by default, or what I've just shown you, I'm only redirecting the standard in and standard out. But you can also specify the standard error You can also redirect the standard error stream. And the way you do that is a more general syntax. So instead of just using the larger, you specify which stream you want to specify. And essentially you have two options, either 1 for standard in or 2 for standard out, standard error, and the end if you want to redirect both. Okay, so let's say you have a script that compiles your model. If you want to, in this first example here, you redirect only the standard output. In the second example, you only redirect the standard error to a text file. In the last example, you redirect both. And so one useful example where this is, where I use this quite often is if you want to print error messages to standard error, right? So by default, if you use the echo command, echo hello world, that will be outputted, the output will come on the standard output stream. But if you want to have an error message, then you should really output to the standard error stream. And the way you do that is use the echo command, just normal, but then you redirect the standard output stream to the standard error stream. So anything that comes to the standard output will instead be outputted on the standard error. And that's the syntax that you use here. Does it make sense? Okay, but okay, so we've learned how to redirect these inputs and outputs to files. But really what we want to do is we want to redirect them to other programs. And the way you do that is through pipes. So the way pipe works is that, let's say we have 3 programs. And the first program takes the input from a keyboard. And then normally it would put all the output to a display. But instead what we will do is we will redirect the standard output to a second program. And we will also change the input of program 2 to, instead of coming from a keyboard, it should take the input from program 1. Right? So these will be connected. If any error messages occur, one typically still wants to have them shown on the display. So we don't redirect the standard error stream. And the same thing with program 2. We connect the standard output and the standard input between program 2 and 3. But the standard error of program 3 will still be shown to the display. And also the output of the final program will be shown on display. And so the coupling here between 2 programs is done with the bash pipe. And that's simply a vertical line here. So what that does, it connects the standard output of one command to the standard input of another command. So first, a very simple example. So let's say I'm interested in listing all the Jupyter Notebook files in a directory tree. So the Jupyter Notebook files, they always have the ending IPYNB. And the way I do that is if I remove that first part of the program, I just have ls star. ls lists all the files in a directory, and if I use ls star, I get all the files in an entire directory tree. So just to make this a bit more interesting, I go one folder up, and so these are all my lectures. Right? And so you see there's a lot of files down here. And some of them are these IPYNB files that I'm interested in, but there's a lot of other files that I'm not interested in. So then what I do is I take that output of the ls file and I pipe it into the grep file, grep command. And remember, the grep command filters lines that have a specific value. So of course, the values that I'm interested in is only the lines that contain the word IPYNB, and that's the output. So now I have a list of all the notebook files in my folder. But now I could operate on them, maybe move them or do something else. Questions? No? Then let's start again at 1:15.